How's it going? Welcome back to Math 100. This is 2.3 applications of sets. We are finishing all of set theory today. Well, when I say all of the set theory, I mean all that we are going to cover in this class. And today we're continuing to work on those set operations that we started learning about last time: complements, unions, and intersections. And my highlighter is a little thin. Let's make it a little thicker. Okay, so what we're really doing though is we're training our brains to think of the world in a whole new way. You're sort of building your brain muscle. That's really what we're doing, in fact, throughout this whole entire class. The other thing is, really anything can be thought of in terms of sets. It's so exciting. It's so exciting. You can describe the entire universe with sets. I think I might have mentioned that before, but it is what it is. Okay, let's move on to the next part. It says we're going to need to know the order of operations for sets. Now, before we talk about that, though, I just want to draw a parallel to something that you probably already know, something called PEMDAS. This is the order of operations for just, normal numbers, right? Except, I think there's a misconception with this acronym, PEMDAS, because it stands for parentheses, exponents, that part is okay. But then the MDIS, that's M and D, right? And so a lot of people think multiplication happens before division, but that's actually not true. They're actually at the same level. And same thing with addition and subtraction. So that's for multiplication, division. I kind of messed that up. I should really write it like this. Multiplication / division. And then addition / subtraction. So addition does not come before subtraction, just like multiplication does not come before division. You just work from left to right if you have both of those things. Yeah. So anyways, I just wanted to remind you that there is such a thing as the order of operations with numbers. And now with set theory, we have a similar idea. We have parentheses first. This is kind of just like the same as in numbers, right? Parentheses coming first all the time. And then second, we have complements. Actually, now that I'm writing this down, I kind of realized I didn't really need to write this down because it's already right here. But I already started, so I'm going to continue. And then unions, intersections. And, that's kind of like the way multiplication division is. Unions and intersections, they have the same level of priority. If you see both unions and intersections, then you're just going to work from left to right. That is, unless, of course, you have parentheses. So parentheses, you got these guys, or you got complements, the lines on the top, unions and intersections, or things like this. Now, there's one additional little sort of hidden rule here. If you see something like this, let's say you have A union B, or you have some other operations, and you see a complement over the top, there's actually really a hidden parentheses there. Okay, so even without having the parentheses written out explicitly, if I see this line over the top, the complement line is over the whole thing, that complement does not happen until I've already taken the union of whatever's underneath, or I've already conducted whatever operations are underneath there. So like I said, the way I think you want to remember that is if you see a big line over a bunch of stuff, just imagine there's invisible parentheses right below that, okay? All right, guys, take a moment just to rest your brain while I erase, let that all sink in. So far, all we've done is we've introduced this idea that there's an order of operations for the set algebra that we learned. And, that's really all that's new today. That's really it. We pretty much know how to do this whole section already. Yeah, so, last section in 2.2, we were introduced to the complements, unions, intersections. There's really not much more theory in this section. And so for that reason, I think this is going to be a relatively fast section. Let's start by just drawing the pictures. Okay, so we're going to practice drawing these pictures of these more complicated expressions. So what I'd like you guys to do is pause the video and attempt it for yourself. Okay, attempt it for yourself. Okay, what I'm going to do is I'm going to draw all of these on a separate paper. Okay, this is number 1. Separate paper, just because I'm going to need my space here. I've got A complement union with B complement, right? You guys are working on your own paper. I recommend making enough space for yourself so that you can draw nice and big and not feel squished in. That's why I'm using a separate paper, and I recommend that you do the same. Okay, that's number 1 and 2. 3 was A complement intersected with B complement, okay? And then 4 is going to be A union B complement, okay? Okay, so those are the four sets that I'm going to draw the general Venn diagrams for. Let's start with number 1. Let's do one at a time. And the first thing I'm going to do is just draw my big set rectangle. And I'm going to label that U for universe. Yeah. I'm using the curl at the end for the U just to distinguish it from the union, because otherwise my U's would look very similar to that. Okay, remember the most general picture for a Venn diagram of 2 sets. You got 2 circles that overlap each other, right? Call the first one A. Call the second one B. And how are we going to do A complement union with B complement? Well, what happens first in the order of operations? Remember, it's going to be the... well, parentheses if there are, but we don't have parentheses. So in this case, it's going to be the complement that happens first, right? So these complements are going to happen individually first, and then we're going to take their union. All right, let's do the complement of A first. That's everything that's outside of A, right? I'm going to shade that here in the yellow. All right, my shading is not going to be perfect here. I'm just kind of using the technique that I learned in kindergarten, which is like shade the border first and then shade inside of it after. Remember when I first saw the girl next to me doing that, I was like, whoa, your shading is so good. You're in the lines every time. Unlike myself. Okay, so it's not going to be a perfect shade, but you get the idea, yeah? We're shading everything that's outside of A, that's the A complement. Oh, I just shaded in the line just now. Okay, that's A complement. Let's do the same thing for B complement. Remember, B complement is going to be outside of B. I'm just going to do the same color again. Here it is, here, That's outside of B. Same thing. Sorry, guys, make you watch this. You can fast forward while I'm doing this shading here. Skip ahead 10 seconds. Or maybe longer. It's going to take me a while. You know what? I made the error of making this too zoomed in. Next time I won't do that. It's too zoomed in. That's why it's taking me extra long here. Okay, so we're everything outside of B, right? That means we're going to get parts of A. Again. Yeah. Okay. So now I've shaded A complement. I've shaded B complement. What does it mean to be in the union? It means anything that's shaded is in the final result, right? So I've just drawn the picture, the Venn diagram. Any part that has any yellow on it at all, that's in the final picture. Let's see if we can just erase that little bit there. Oh. Okay. It's better. A little better. Okay. Yeah, so anything that has any yellow at all, that's in the final result. The whole yellow portion. Even the light yellow portion, it's all in the result. The only part that's not in there is this part that I'm going to just highlight in red here, draw over in red. Only this part in the middle does not get highlighted. That's not in the union. Okay, let's do the same thing for 2. A intersect B complemented. So this time, we're going to use that fact that I mentioned earlier. If you've got something with a big complement over the top, then it's as if there was an invisible parentheses here. You're going to do everything under the line first. That means I'm going to take the intersection to start, okay? So let's draw the big rectangle again. And so as not to repeat that same mistake as last time, I'm going to zoom out a little bit. It'll just be hopefully a little faster. Here's my universe. Here's the set A. And then the set B. There's A, there's B. Okay, so first, the intersection. What's the intersection? I'm going to do that one in light red color, light red highlighting. So the intersection is right here in the middle, right? Remember, parentheses first, or if there's a big complement, it's as if there's an invisible parentheses. So that's the part I'm starting with. A intersect B first. Now, once I have A intersect B, what I'm then going to do is I'm going to take the complement of that, which means I'm going to shade everything that's outside of that pink shaded area. And what do you think you're going to get? Yeah, you can kind of fast forward ahead to see where I ended up shading, but it's going to be really the same result as the last picture. Let me pick the same color. Sorry, I picked the wrong color. Same result as the last picture, right? When I did number 1. You see that? So which part ends up being shaded in my final result? Final result being this yellow portion. It just happens to be, actually not just happens, it's not a coincidence. It just turns out to be the same thing as it was in the number 1. Very interesting. In fact, this is an important fact. It actually has its own name, but before I tell you what that name is, we're going to do numbers 3 and 4. Okay. Okay. Shade. Okay. And if you want to be just extra clear, maybe I can use this eraser, see if this works. Oh, yes, beautiful. Yeah. So you see the results for numbers 1 and 2 are exactly the same. All right, let's move on to 3 and 4. Same idea. And before I move on, I think I'm going to increase the size of my highlighter for the next time. Okay, 3. Okay, made that too big. And it's not even a rectangle. Try again. Okay. So same start as always. I got my universe here. I'm going to have my 2 sets A and then B. Here's A, here's B. Okay, this time, what's first? I've got A complement intersected. That's really an ugly intersect. Let me redraw that in. A complement intersect B complement. The complements happen individually first, right? So just like the last time, very similar to the last time. In fact, yeah, it's going to be the same start. We're going to start by shading outside of A. That's A complement. Thicken my highlighter, which means I might just go out the lines a little bit more this time. That's okay. At least it'll be faster. Okay, so this is A complement I'm shading right now. Okay, and next is B complement. That's outside of B. It's going to be this portion here. Which also includes parts of A. Okay. So I've shaded so far A complement, I've shaded B complement. What ends up in the final picture? This time it's the intersection, right? The intersection. So intersection means I must have basically the double colored parts. And just to be extra clear where that is, I'm going to just go over that part in the pink. So the parts that have the double coloring, that would be all this area, basically outside of A, outside of B, like this. Just imagine that I'm not going over the lines, but that's the idea. Get all that area over there. So everything that's not in A, and at the same time it's not in B, right? That's what that means. A complement and B complement, right? So it's that orange, kind of orange looking portion now. I guess because pink and yellow makes a light orange. All right. I wonder if this will work. Oh yeah, that works. Oh yeah, actually, there you go. So that's the end result. I erased the extra shadings I didn't want, and yeah, that's what we end up with that pink part. Okay. Number 4. And you might have guessed what's going to happen here. Maybe, maybe not. Maybe this rectangle won't listen to me. Come on, yes. I think my highlighting thickness was like a little bit too much. Okay, so here's the universe. Here's A. And here's B. Okay, this time, just like before, I've got a complement over some compound set here, right? So what that means again is that it's as if there's a hidden parentheses. The union should happen first. Okay, so the union happens first. Here's my A. Here's my B. First step is going to be to take that union. Let's do that in the yellow. So the union, we saw this from the last class, right? We drew this same picture, A union B. So everything that's in A or in B, which means you get everything all together. Like that, right? And then from there, I'm going to take the complement. So that's going to mean everything that's not that set, or in other words, everything that's outside of that yellow shaded area. And it's kind of fun to like play with these colors like this. You can see the appeal of being a first grader. Okay, that was a little out of lines, but yeah, you know, get the idea. Okay. So now now that we've drawn the part that we wanted to, colored the part that we wanted to, let's get rid of the superfluous coloring, and that's the result. And look, number 3 is the same as number 4, just like number 1 was the same as number 2, right? And combining all these facts, we've drawn the most general Venn diagram for all cases, right? So that means we account for every single possibility of A and B. So what we've just essentially shown is something that we call, it's so important, it has its own name. It's called De Morgan's laws. And these are De Morgan's laws for sets. Later on, we'll come across De Morgan's laws for logic in the next chapter, but that's not this chapter. Okay, so there's 2 parts to De Morgan's laws. Part 1, if I take A complement and I union it with B complement, then the resulting set is equal to, if I take A and intersect it with B, and then I take the complement. And then 2, similar idea. If I take the individual complements and this time intersect them instead, and that's going to be equal to the union complemented. How do you remember this thing? Basically, there's 2 steps to remember it. Oops. 2 steps. Step 1. So yeah, from you can go back and forth from either side, right? Let's say I'm starting from this side where the complements are separate. So change separated complements to one big complement. Or vice versa, right? If you start with the big complement, you can separate it out into 2. You can go in that direction. Or if you have 2 separate complements, you can combine them to make one big one. That's the first step. Okay? Second step, just flip the union, or intersection. So if it started off as a union, it's going to flip to an intersection. If it started off as an intersection, it's going to flip to a union. And that works also from this direction, for number 2, right? Step 1, I have my separate complements. I'm going to combine them to one big one. That's step 1. Step 2, if I had an intersection, I flip it over to a union. Right? Those are the basic steps. Just kind of like a little tiny mnemonic to remember what the change is from going from one stage to another. So that allows us to do things like this. So let's say I have a set. Let's say you start with any of the 4 starting positions, okay? So stay started with, wait, let me look ahead to my questions first. Okay. Okay, so after this, I'm just going to give a couple of quick examples and we're going to end this video. So that means if I start from any of the beginning positions, let's say I started, I'm just going to pick a random one. Let's say I start from A intersect B complement. I think, okay, how can I apply De Morgan's laws to rewrite this? I know, okay, that is, I had one big complement to start, so I'm going to split it into two. And I started with an intersection, so I'm going to change it to a union. And I know that's an equivalent form applying De Morgan's laws. Now, it doesn't only apply to A's and B's too, by the way. What if I had a C and a D? Okay, same thing. I'm going to take this big complement. I'm going to split it into two. I have this intersection to start, flip it over to a union. That would be the application of De Morgan's laws to write an equivalent form of the same set. Let's try one more. Let's say I started with these are other letters here. Just go up the alphabet. Let's say I have E complement intersected with F complement. How can I rewrite that using De Morgan's laws? Okay, well, I started this time with two separate complements, so I'm going to change that to one big one. And on the left, I started with an intersection, so let's change that to a union. And there it is, application of De Morgan's laws, writing an equivalent form. All right, let's cut this video off. I will see you guys in the next one.